let's say you have a neutron star. And you take out a piece of neutron star that is the size of a grain of sand. A neutron star, it's it's got a mass that is more than that of the sun, but it is compressed into a diameter of about 20 kilometers. That is shockingly dense. That is more than nuclear density. And that's why what you have in a neutron star is mainly neutrons only. It has a thin atmosphere of iron plasma, and inside you've got strange, very weird matter which is called nuclear pasta and all. But overall, it's nuclear density. Extremely dense, incredibly dense. So, what if you take a tiny bit of a neutron star, the size of a grain of sand, and you somehow are able to transport it to Earth, and you release it into the Earth's atmosphere? What happens is the question. That is the big question. It's a fantastic thought experiment. So if you take this sand grain piece of neutron star, bring it into the Earth's atmosphere, release it there, will it remain intact? It won't remain intact. See, outside of the gravity that a neutron star provides, that bit of material is violently unstable. It will decompress explosively. It will turn into an exploding fireball, a ball of plasma. Okay. And it will be made of neutron rich matter, and a tremendous amount of energy will be released. Much of it will be released in the form of neutrinos, most of which are harmless, but the tremendous amount of energy. So the question is, how much energy is released in terms of kilotons of TNT? So look, roughly the density of a neutron star is about 10 raised to 17 kilograms per cubic meter. That's one with 17 zeros after it. Those many kilograms per cubic meter. So the mass of a neutron, okay, if you take a grain of sand, let's say half a millimeter, then its mass of that little bit of material is about 20 million kilograms. It's the mass of an iceberg, medium-sized iceberg. And how many nucleons does it contain? It will contain about 10 raised to 34 nucleons. And assuming that the energy released per nucleon is about 10 MeV mega electron volts, you will find that the energetic output, is of the order of 10 raised to 22 joules. If you convert that into terms in terms of tons of TNT or kilotons of TNT or gigatons, you find that that's about 5,000 gigatons of TNT. 5,000 gigatons of TNT, assuming 10 MeV per nucleon. So what is 5,000 gigatons of TNT? The most powerful nuclear weapon ever tested was the Tsar Bomba, Russian weapon. Its energy output was 50 megatons of TNT. So one sand grain sized bit of neutron star matter will give you 5,000 gigatons of TNT. That is 1 lakh Tsar bombas, 100,000 Tsar bombas. Another way of comparing, the Chicxulub impact event that killed off the non-avian dinosaurs, it gave off about 10 raised to 23 joules. So the 5,000 gigatons, it's about roughly 1/5 of that. So if you release a sand grain sized piece of neutron star matter into the Earth's atmosphere, it's going to have a very similar effect as the Chicxulub impact event. It is not a city killer, it's a planet killer. It will cause an extinction event. It will be a disaster. Imagine that, a sand grain sized bit of neutron star matter, you release it into the atmosphere, it will devastate the world. It will cause an extinction event similar to the asteroid that killed off the non-avian dinosaurs. That's how frightful this is. This is all order of magnitude calculations. I'm not giving you exact calculations because you can't really estimate everything properly, but it's about 5,000 gigatons, maybe 4,000 gigatons, around, that sort of ballpark we're talking about.